day everyone, welcome to the channel. In this video, we'll talk about seeing the world as the shell sees it. In this chapter, our focus will be on uncovering the wizardry that unfolds on the command line with the press of the enter key, exploring various intriguing and intricate aspects of the shell. We'll achieve this using only a single new command. The command is echo, which displays a line of text. Now let's talk about expansion. Whenever you input a command line and hit enter, Bash undergoes multiple processes on the text before executing your command. We have observed instances where a seemingly straightforward character sequence like the star character holds significant meaning for the shell. This transformative process is known as expansion. Through expansion, what you input is transformed into something else before the shell takes action. To illustrate, consider the echo command, a built-in shell function with a basic purpose, printing its text arguments onto the standard output. We saw an example of this command in the previous lesson. Let's quickly have a look again. We'll say echo. This is a test, and when we press the enter key, it is going to print that text back to us, which is this is a test. All right, that's quite simple. Any input given to the echo will be shown. Let's explore another instance. So when we say echo star, it will display all the folders inside the home directory. So let's say let echo star, and all the folders or all the directories inside the home directory are displayed on the standard output. Okay, what just happened? Now you might be wondering, why didn't echo display star? As we have previously learned about wildcards, the star symbol signifies matching any character in a file name. However, what we didn't explore earlier was how the shell accomplishes this. Simply put, the shell transforms the star symbol into something else, in this case the names of the files in the current working directory. Before executing the echo command, upon hitting the enter key, the shell automatically expands any applicable characters in the command line before executing the command. Okay, therefore the echo command never encounters the star. It only receives its expanded outcome. Understanding this clarifies why echo behaves as anticipated. Okay, so what are path name expansions? Wildcards operate through a mechanism known as path name expansion. If we apply some of the techniques used in our prior chapter, we'll observe that they essentially involve expansions. Considering a home directory structure like this, so our home directory structure looks like this, we could carry out the following expansion. We can say echo d star. Now what is going to happen? It is going to display all the directories inside the home directory that starts with a D. All right, and when you say echo star S, it is going to display all the directories that end with an S. So when you press the enter key, you'll see all the 3 directories that end with an S. Now, or even you can say upper. So you can even use this particular regular expression. What this means is, let's quickly type it out first. What it means is any directory that starts with an uppercase letter and any uppercase letter and then followed by anything after that shall be displayed. So if we press enter, all the directories that start with an uppercase letter are displayed. So let's quickly make a directory and call it a foo, but the F in that name of the directory is of the lowercase. Okay, so now if we press the ls key, the foo directory is here. But now if we enter the echo command with this regular expression, the foo is not displayed. Okay,
Unlock the world of Daisy Ninja puzzle books, where excitement meets brain power. Dive into the mind-bending labyrinths of May's mastermind. Conquer the Sudoku challenges in Sudoku Ultimate, uncover hidden words in Word Search Wizard, and decode mysteries in Word Spy Adventures. Whether you're soaring above the clouds or speeding down the tracks, turn your downtime into brain-boosting fun. Perfect for all ages, these books guarantee hours of entertainment. Daisy Ninja Puzzle Books, your passport to endless excitement on the go. New release each month.
And looking beyond our home directory, echo, let's check this out. We'll say echo user slash star slash share. It is going to show us this particular directory within this particular system, but over here on your system it may show multiple directories. Okay, what are path name expansions of hidden files? As we are aware, files starting with the period are hidden, and this behavior is respected by path name expansion. When we perform an expansion like this, which is echo star, it doesn't display hidden files. Initially, it might seem possible to incorporate hidden files in an expansion by commencing the pattern with the leading period as shown here. So yeah, you might wonder, echo dot star might display all the hidden files. Well, it's nearly effective, yet upon closer inspection of the outcomes, we'll notice that the name dot and the double dot are included. These names point to the current working directory and its parent directory, potentially leading to an inaccurate result. If this pattern is used to illustrate, let's try this command. So let's say ls-d dot star pipe the output to the less command, and as you can see, it is also displaying the previous directory shortcut. For more accurate path name expansion in this scenario, we need to utilize a more precise pattern, and that pattern would be echo dot, then not a dot, then star. So what this means is any name that starts with a dot, then the next character is not a dot, and then other than that it could be anything. Okay, so when we press the enter key, the output does not show the previous directory shortcut. Okay, so this pattern encompasses file name that starts with a single period followed by any character but not a second period. Okay, as I mentioned here, it accurately encompasses most hidden files, although it still excludes file names with multiple leading periods. Using the ls command with the -a option, almost all will guarantee an accurate listing of hidden files. So you can just use this command instead. So now what's tilde expansion? As we discussed during our introduction to the cd command, the tilde character, this character, holds a unique significance. When placed at the start of a word, it expands to represent the home directory of the specified user, or if no user is named, the home directory of the current user. Okay, so if you say echo tilde, it is going to display the home directory of this particular user over here, and that's the same as here. Okay, so if the user foo has an account, then echo tilde foo will be showed. So this system does not have any other accounts on it, so we can just display the example with the same user that we had earlier. So it is just going to display the directory for that particular user. Okay, so if you have multiple users on your system, you can test this command out with all those different users. Okay, so let's look at the arithmetic expansion. Expansion in the shell permits arithmetic operations, enabling us to utilize the shell prompt as a calculator. So you can even use echo with some arithmetic expansion. So you can say 2 plus 2. Okay, so the dollar sign represents that there is arithmetics needs to be done. So when you enter this command and you press the enter key, you'll get the answer. So the arithmetic expansion uses the following form. Okay, so it's this, and inside that the expression that you are seeking the answer for. Okay, where the expression comprises values and arithmetic operators to form an arithmetic expression. Arithmetic expansion exclusively handles integers, whole numbers without decimals, but can execute various operations. Below are some of the supported operators. Okay, so you can have a look at these. So spaces hold no significance with arithmetic expressions, and these expressions can be nested. For instance, to calculate the product of 5 squared by 3. Okay, so we'll say echo the $sign. Then for a nested expression, we'll type another $sign, and then we'll say 5, which means 5 square times 3, and then we'll close the expression, and the result is 75. Let's move on. Using single parentheses allows for the grouping of multiple sub-expressions. Employing this method, we can revise the previous example and achieve the same result with a single expansion instead of two. An easier way of doing the same would be this way. Times 3 and the close of the expression. Okay, so rather than having two expressions, nested expression, we can just use brackets to achieve the result of this, then multiplying that with 3, and that all of that is within one single expression. Okay, so if you press the enter key, you'll get the same output. Okay, here's an illustration employing the division and remainder operators. Observe the outcome of integer division, right? So you can even say echo 5 divided by 2 equals, then you can enter your expression, that is 5 divided by 2, and when you press the enter key, it is going to give you 5 divided by 2 equals 2, which is of course incorrect because it only displays in integer values and not the decimal values. Okay, so you can also say echo with the $5 left over, so it will say with 1 left over. So basically, if you keep dividing 5, what it says is if you keep dividing 5 by 2, at the end you are just left with 1. Okay, arithmetic expansions is covered in greater details in chapter number 34. All right, so now let's look at the brace expansion. One of the more peculiar expansions is known as brace expansion. Through this, you can generate multiple text strings from a pattern that includes braces. Take a look at this example. Echo front dash, then curly bracket A, B, and C dash back. Let's quickly type this command out. First A, comma, B, comma, C, and B. So it is going to go through this list and it is going to print each character one by one and then display the result. Okay. Okay, I think I made a small mistake. I don't think you can add spaces here, and now you can see the result as we were expecting. All right. Patterns eligible for brace expansion might consist of a leading part known as a preamble and a trailing section termed as postscript. Within the brace expression, there could be a comma-separated string, list, or a range of integers or single characters. The pattern must not include spaces, as I added spaces in mine. That caused the problem. Take a look at this example featuring a range of integers. Right, so let's look at another example, and now we're going to say echo numbers or number, then the curly bracket 1 to 5, and then closing the curly bracket. Now it is going to print number underscore 1, number underscore 2 up till the number underscore 5. Integers may also be zero padded like, so you can say echo 1, then 2, number 15, and then when you print it, it'll say 0, 1, 0, 2, 0, 3 till 0, 9, then 10, 11, 12, 13, 14, and 15. If you add one more 0 over here and here, it is going to print the numbers like this. Okay, a range of letters in reverse order can be printed like this. We'll say echo Z or Z to A. Okay, now it is going to print all the alphabets in the reverse order. Brace expressions may be nested. So an example of that is echo small a, then the capital A, then 1 comma 2, close the curly bracket, then B, curly bracket 3 comma 4, closing the curly brackets, B. All right, so what that is going to produce is this. The first character would be A in all these series, and then the next character is going to be either A or B. First it's going to be A, then it's going to be B, so it'll be A. Then the nested list would be 1, then A2, and of course every expression has to end with the B, as we have mentioned here. So yeah, the only difference is it's going to be A1, A2 over here, then B3, and then B4 over here. Okay, the first and the last character will remain the same. Okay, so what purpose this serve? Primary use is creating lists of files or directories to be generated. Consider a scenario where as photographers we possess an extensive collection of images that require organization by years and months. Our initial step might involve creating a sequence of directories labeled in a numeric year-month structure. To ensure a chronological sorting while manually listing all directories is laborious and error prone. There's a more efficient way to accomplish this. So we can say we already have we don't have the photos directory, so we can say mkdir photos, then we will move inside the photos folder. Okay, there's nothing in here, so then we'll say mkdir and then the curly bracket, and we'll say 2020 till 2023 dash 01 up till 12, and then closing the curly bracket. So what is it is going to do is it is going to create directories that are going to 2020, then 0 dash 01 02 03 04 up till the number 12. Then it is going to create 2021 dash 01, then the 2021 02 03 12, and then finally it is going to create the, once it's done with the 21 then 22, it's going to create the 2023, which is also going to be in the same pattern, which is dash 01 and dash 02 dash 03 up to 12. Okay, so when we press the enter key we won't see anything here, but once we type out the ls command you'll see all the directories that were created. So 2020-01, 2020-02, 03, 04, 05, 06 up till 12, then it moves to 2021-01, 02, 03 and so on, and it ends at 2023-12. All right, so it's a pretty handy and really easy way of achieving this. Okay, so parameter expansion. In this chapter, we'll briefly introduce parameter expansion, but we'll delve deeper into it later on. This feature is particularly valuable within shell scripts rather than directly on the command line. Its capabilities revolve around the system's capacity to store small data portions and assign each a specific name, commonly referred to as variables. Numerous such variables are accessible for exploration. For instance, the user variable holds your username. To employ parameter expansion and display the contents of user, you would execute this command like the following. We'll say echo, then the name of the variable. Remember, the name of the variable always starts with the $, and the displayed output would be the name of the user, which is in this case is Devrishi. Okay, to see a list of available variables, try this. So we'll say print env, then pipe that to the list command, and these are all the variables available on this system. All right, so you can use the R key to go up and down. Right, so variables are these, the ones in the capitals, and these are the values stored inside those variables. Okay, so while working with other expansion types, mistyping a pattern prevents the expansion, leading the echo command to display the mistyped pattern. However, in parameter expansion, if you misspell a variable name, the expansion proceeds, but results in an empty string instead. So if you mistype a variable name, the output is going to be nothing, just a blank line. Okay, so let's talk about command substitution. Command substitution enables us to utilize the output of a command for expansion. So you can say echo $ls and then the closing bracket. So this is going to display all the files in the home directory or the directory that you are currently in. One of my favorite goes something like this, which is ls-l, then the $ bracket, which cp, and the closing bracket. So the output looks like this. In this instance, we utilize the output which cp as an argument for the ls command, obtaining the list of the cp program without requiring its complete path name. This method isn't restricted to basic commands. Entire pipelines can also be employed. Only a particular output is displayed. So you can say file and the $ls-d/bin/star, pipe that to the grep command with the zip filter and then the closing bracket. And when you do that, it is going to display this output. Okay, in this instance, the argument list for the file command was populated by the result of the pipeline. Right, so older shell programs and bash support an alternative syntax for command substitution using back codes, this character, instead of the $ and the parentheses. So now let's talk about quoting. Now that we have explored the numerous ways the shell executes expansions, it's essential to understand how we can manage this process. Consider, for instance, we'll say echo, this is and we'll add multiple spaces, then we'll type test and we press the enter. All those spaces have been removed. Or we can say echo the total is the $100 decimal, then double zeros. The output is 0.00. In the initial case, the shell's word splitting action removed excessive white spaces from the echo command's argument list. So over here, in the subsequent example, the parameter expansions replaced an empty string for the value $ preceded by a 1, which was over here. Due to it being an undefined variable, to selectively suppress undesired expansions, the shell offers a mechanism known as quoting. So what the shell thought that this $1 was a variable, but it wasn't. It couldn't find it, so it just replaced it with an empty space. So to avoid this issue, we'll use the facility of double quotes within the shell. The initial form of quoting we'll explore involves double quotes. When you enclose text within double quotes, the special characters used by the shell lose their unique significance and are treated as regular characters. Expansions to this rule are the $, and the backslash and the back quote. This implies that word splitting, path name expansion, tilde expansion, and brace expansions are suppressed, while parameter expansion, arithmetic expansion, and command substitution still occur. With double quotes, managing file names containing spaces become feasible. For instance, imagine having a file name called 2words.txt. If used on the command line without quotes, word splitting would treat it as two separate arguments instead of a single desired argument. All right. So if we look into our directory, we have a file called 2words.txt. So if we type out the command ls-l 2words.txt, it is going to give us the following error, which is no such file or directory called 2 and no such file or directory called words.txt. Employing double quotes prevent word splitting and yields the desired outcome. Moreover, we can even rectify the resulting issue. So To get the correct output from this particular scenario, we'll say ls-l, then we'll put the name inside double quotes like this, and then we'll press the enter key and we'll get the correct output. To avoid this problem in the future, you can use the naming convention where we replace all the spaces with underscores. So to do that, we can say mv words.text and then words.text. Okay, so now if you type ls-l and then we'll say words.text, we don't have to enter the name inside the double quotes and it'll show the same output. This naming convention with the underscores replacing the spaces in the file name is very common in the world of Linux. Okay, keep in mind that within double quotes, parameter expansion, arithmetic expansion, and command substitution remain active. Let's look at this command. 2 plus 2 double brackets, then the cow command. Okay, so now what it has done is it has displayed the word user. The reason is we forgot to actually add the $sign which assigns which declares it as a variable. So now if we press enter again, you'll see the username is pressed, then the sum of these two number is displayed, then the result of the cal command, which is this. Okay, the cal command is an actual program, so it has to be installed externally. So let's examine the impact of double quotes on command substitution. For a moment, let's examine the impact of double quotes on command substitution for a moment. Before that, it's beneficial to explore how word splitting operates more intricately. In our previous example, we observed how word splitting seemingly eliminates additional spaces in our text. So as we saw earlier, if we do echo, this is a couple of spaces. Test, those spaces were eliminated. By default, word splitting identifies spaces, tabs, and new lines as delimiters between words. Unquoted spaces, tabs, and new lines are treated as separators rather than part of the text. Consequently, they divide words into separate arguments. In our command line example, there is a command followed by 4 distinct arguments. Due to this separation, however, we introduced double quotes, and that fixes the issue. All right, so now it knows that this is only just one argument inside the quotes rather than 4 different arguments, and it prints the result as it's supposed to be. Word splitting is suppressed and the embedded space are no longer considered delimiters. Instead, they become part of the argument. Upon adding double quotes, our command line now consists of a command followed by a single argument. The treatment of new lines as delimiters in the word splitting mechanism leads to an intriguing yet a subtle impact on command substitution. Take this into consideration. So if we say echo $, then the cow command, it is going to print everything in just one line. But if we do this, it is going to print the actual result as it's supposed to be. Initially, the unquoted command substitution led to a command line comprising 38 arguments. However, in the second instance, it generated a command line with only one argument that encompassed both embedded spaces and new lines. So single quotes, when we require the suppression of all expansions, single quotes come into play. Here's a comparison between unquoted, double quotes, and single quotes. Okay, so let's check the result of this command. So we'll say echo text tilde/star dot text, then the expression a comma b, then echo foo, then the $sign 2 plus 2, and when we press the enter key, we'll see the word text written, then the directory, the current directory, the home directory with all the text files, then A, then B, then foo was echoed, then the result of this expression. So if we, instead of the above, if we add quotes to this whole command, we forgot to add the user variable, but we'll do it over here. And as you can see, it has just printed the whole text, but it has executed this particular command and this particular command, and also revealed the result of the user variable. So now if instead of using double quotes, we use single quotes, our result will look like this, okay, which is basically displaying the text as we passed back to the standard output. Okay, notice how we progress through each level of quoting and increasing number of expansions get suppressed. Escaping characters. Occasionally we might only need to quote a single character. To achieve this, we can place a backslash before the character, utilizing what's known as the escape character. In this context, typically this is done within double quotes to selectively prevent an expansion. So to do that, we'll say echo the balance for the user, then the user variable is $$5, and then closing the double quotes, and when we press the enter key, it has retrieved the user variable and displayed the correct amount. But if we used single quotes, it would not have done that, and it would have just printed the line as it was, which you can see here. So using escaping is a common practice to nullify the special significance of a character within a file name. For instance, it's feasible to incorporate characters in file names that typically hold special meaning to the shell, such as the $sign, the exclamation mark, and the ampersand sign, spaces, and others. To include a special character in a file name, you can achieve this by the following method. So to achieve that, let's first have a look that we have a file called bad and file name. So to fix the problem, and we'll move this to the good file name. So how we are going to do that is we'll say bad backslash and, because and is character that's used by the bash system. So we'll say bad backslash, that is the escape character, and file name, and we'll move it to a good file name. Okay, so now if we look at the result of the ls command, we have seen that the bad and file name has been changed to good underscore file name. Okay, to include a backslash character, escape it by typing slash. It's important to note that within single quotes, the backslash loses its special significance and is interpreted as an ordinary character. Backslash escape sequence. Apart from its function as the escape character, the backslash is employed as part of a notion representing specific special characters known as control codes. The initial 32 characters in the ASCII coding scheme are utilized to transmit commands to teletype-like devices. While some of these codes are familiar, like tab, backspace, line feed, and carriage return, others may not be, such as null, end of transmission, and acknowledgement. Okay, so these are some of the escape sequences and their meanings. Have a look at them. So slash A is bell or alert, cause the computers to beep. Slash B is backspace. Slash N is a new line character. Slash R is a carriage return, and slash T is a tab. Okay, the provided table illustrates several prevalent backslash escape sequences. This representation using the backslash originated in the C programming language and has been adopted by numerous others, including the shell. When you add the -E option into echo, it activates the interpretation of escape sequence. Alternatively, you can enclose them with the $ and single quotes. To demonstrate, consider using the sleep command, a basic program that waits for the specified number of seconds and then exits. To create a simple countdown timer, you can do the following. Say sleep 10 echo dash E time is up. Okay, we could also do this, sleep 10 echo times up and $/A. All right, so you can try this command on your system. If I do, my system will go to sleep. So let's summarize the chapter. As we progress in working with the shell, we'll notice expansions and quoting become more prevalent. Hence, it's valuable to gain a strong comprehension of their functionality. In fact, some might argue that these are among the most crucial topics to grasp regarding the shell. Without a comprehensive understanding of expansion, the shell might always seem enigmatic and puzzling, leading to untapped potential and wasted power. So I'll end the lesson over here. The links to these notes are provided in the description. Do go through the notes, do practice your commands, and in the meantime, have a good one, and I'll see you in the next video. Take care. Bye-bye.